Welcome back. I'm Mark Dumas, and this is episode 3 of the Laboratory of Irreproducible Results. We're developing an interactive electronic sculpture. We started off in episode 1 by developing this tile. It's a building block made from a 3D printed platform to help me organize these 16 motors and a little bit of electronics, all to control the motion of these mechanical pixels on the visual side of the piece. In episode 2, we doubled the size. I built a second one of these, and we started looking at ways to connect them together into bigger, more interesting sculpture pieces. We also started putting these bicycle chain bits on the front to provide a little bit more interesting visual effect. So here we are in episode 3. I'm getting a little bit tired of writing programs that do canned motion sequences of these mechanical pixels. So what we're going to do in this episode is start looking at ways to make the piece interactive. In other words, make it move in response to the observer of the piece of art. So in preparation for this episode, I've doubled the size of the sculpture again. So now we have 4 of the building block tiles. You can see that each time I added one of these, I simply connected it electrically by using these jumpers here. And I'm using the new wiring scheme, which has this relatively heavy gauge wire with these smaller gauge drops to the DuPont connectors to the PCB board. So that's a lot of servos. And from the front, we've also duplicated the visual part using the bicycle chain. I can see I've dropped one here. See if I can snap that back on real quick. And I did the simple thing of updating the canned routines. So let's plug in our Arduino. First thing that will happen is the center, and then go do the wave. Except now we have 64 chain bits doing the wave instead of the 32 as we had last episode. And then we'll go into the random mode again. All right, so let's get some interactivity into this thing. One of the techniques that I've used on some previous sculptures is to take a canned sequence of motion but trigger it with some sort of user interactivity like motion. And the way I'm going to do that here is with these little sensors right here. These are photocells, and their resistance varies based on how much light is hitting them. And I've got them wired into a simple voltage divider there, and so the Arduino is registering a variable voltage depending on how much light is hitting those photocells. And the program in the Arduino is looking for the case when the left photocell gets darkened, followed by the right photocell getting darkened. And when it detects that, it triggers one of those wave sequences, kind of left to right. And the Arduino is also looking for the case where the right photocell is being shadowed, followed by the left one, in which case it will make all of the servos spin the other way. So let's see how that works. Left to right, right to left. These aren't the droids you're looking for. These are. Okay, so that's good for a few minutes of entertainment, but I thought it would be helpful just to show that really simple sensors can really spice up a dynamic project like this. All right, let's get some more sensors in on the action here. I found this really cool infrared sensor on this little red card. It uses the same infrared technology that's in your floodlight in your driveway that lets you know when the boogeyman's coming. But the big difference here is that this integrated circuit in the middle actually has 64 different infrared sensors. They're laid out in an 8x8 grid, which just happens to be the same configuration as a current sculpture, so I thought that was a match made in heaven. Before I go on, I just want to give a shout out to SparkFun, the company that makes this little breakout board. This is another company that does a wonderful job of taking these high-tech chips, in this case this Panasonic infrared chip, and getting it onto a circuit board with just enough support componentry and connectors to make it easier for experimenters and artists like me to use the thing. So the thing that is interesting about this sensor too is that in addition to 2 power wires, it communicates to the outside world on the same I2C bus that we've been using all along between our Arduino and the servo controllers. So all I had to do was hook up those 4 wires and we're off and running. Now, and then it's just a matter of, a simple matter of programming on the Arduino, and it really is fairly simple. All I've got it doing is going through a loop 64 times. It reads 1 infrared reading from the sensor board, which comes in as a temperature, and then it converts that to a rotation angle for a servo, and then it goes back and does it for the next infrared element in the sensor, and it does that 64 times and then just keeps repeating one after the other. So let's hook it up and see what happens. All right. So it's infrared, so that's responding to heat, and you can see right off the bat that it responds to just the heat of my hand. And if I'm careful, you can kind of see where my hand is relative to the sculpture. But if you really want to get things going, you need a lighter. All right, so you get this in front of it. Oh yeah. You can tell on the sculpture exactly where the hot tip of that lighter is. I can hit the corner, go along the top, down the side, along the bottom, all around. Oh yeah, and look at this. So even with the light out, the tip here is still hot. So it's still emitting infrared. So you can see in the sculpture where the hot tip of this thing is, even though there's no flame. Cool, huh? Okay, let's bring episode 3 to a close here. I've had some fun making the sculpture a little bit more interactive. I don't think I'm going to continue using the grid eye. It's been a lot of fun, and it was certainly a good size of sensor for this size of sculpture, but I do want to make the sculpture bigger, and there's just not enough sensors on that grid eye to keep going. And I'd like to do something that uses visual light. So that's what I'm going to be working on over the coming weeks. Now, I'd love to hear from you in the comments. Excuse me. Have you got any comments on the way you think this project ought to go? I'd love to hear from you. If you've got any questions about how I've done things, either in the code or the hardware, I'd be happy to hear from you. Until next time, keep on making.